Hey guys, so we've now finished the first part, which is determining the maximum impact force exerted on the post by the tugboat. The next part we'll be looking at is calculating the maximum horizontal distance the top of the post will move due to the impact from the boat at point C. So we now know the amount of force being used here, and what we can do is we can use that force to try to calculate the deflection of the top of the post. So we can summarize what we know on a new sheet of paper. So we have a cantilevered beam. Let's write it here. There it is. And the cantilevered beam has a force. The force is equal to 3.79 kilonewtons. The location of that force is a total of 3.6 away from the bottom, and the distance from the top section here is 0.9 meters from that point. Now if we turn this question on its side, this just looks like a cantilevered beam. So we're going to be using the cantilevered beam equations for this. Alright, so I'll just bring up those equations here. Here we go. And for this beam, we have some calculations for your stresses and for your deflections. We want to find out the maximum deflection at the end, and that's governed by this equation here, circled in green. Alright, so we can write down X max is equal to W L squared divided by 6 EI times 2L plus 3B, where this distance at the base here is L, this distance is B, and W is the magnitude of the force, and E and I modulus of elasticity, and our second moment of area for bending in that section as well. Alright, so W is 73.79 times 10 to the 3 times our length L, 3.6 squared divided by 6 times E, which was given as 9.86 times 10 to the 9 times I for that section. So that'll be pi times 0.3 to the 4 over 64, and then times 2 times L plus 3 times B. Okay, so we just plug this all into a calculator. Okay, divided by 6 times 9, 860, 1, 2, 3, 4, 5, 6 times pi times multiplied by 64. Alright, so that's our deflection in meters, so that'll be 40.7 millimeters. Okay, so that concludes part B. For part C, we'll be looking at calculating the stress developed inside this beam. So we'll see you in the next video. Thank you.